I just want to say welcome to another session of Learning Together, sponsored by the BROSIS Foundation. Our goal, our aim, our mission is to offer additional resources for students who might be struggling in English and math. Today is another math session, and our emphasis really is going to be on how to find the area of a triangle that is not a right triangle. That's going to be our main focus. Last week or last session, we dealt with the trigonometric ratios, sine, cosine, tangent, along with their reciprocals, cosecant, secant, and cotangent. So today we're going to transition over into focusing on non-right triangles and how to find the area of those triangles. So stay tuned and let's get started. Okay, first thing first, I just want to remind us of the trig functions. And one of the things that we learned was we could use this you could use SOHCAHTOA as a way of remembering, just a simple way of remembering the different trigonometric ratios. So we have, for example, sine of theta is equal to opposite over hypotenuse. If you look SOH, sine is opposite over hypotenuse. Cosine of theta, where theta is your angle, is equal to adjacent over hypotenuse. Cosine adjacent over hypotenuse, and tangent of theta is equal to the opposite over the adjacent. We also discussed that you must have a right triangle. You must have a right triangle in order to use the trigonometric ratios as defined with the names of the sides: opposite, adjacent, hypotenuse. We also discussed that if this is the angle theta that we're focusing on, we also know that the hypotenuse is always across from the 90 degree. The opposite is the one that is over here, opposite your angle, and the adjacent is beside. So those were the major highlights from last week. So now we're going to transition over into non-right triangles. So in a previous session, we discussed that if you have a right triangle, then the area is equal to a half base times height. But in order for you to be able to do this, you need to know the base, you need to know the height. So if I gave you a triangle that looks somewhat like this, and it's not a right triangle, you could use this as the base, but you will have to calculate the height in order to use a half base times height. If you don't know the height, you cannot use this formula. Similarly, if you have a triangle that looks somewhat like this, in order to use that formula, you have to extend the base, drop a perpendicular, and you have to find some method to find this height. Without knowing the height of the triangle, you cannot use a half base times height. So our focus today is how can we get around this type of situation? And I have two methods that I'm going to discuss today. Two methods to find the area of non-right triangles. So I'm going to go with the first one. So, as I explained the theory behind this, it might look a little complex, but when we do the example, you're going to say, oh, that's all it is? So bear with me. The theory might look difficult, but the actual application is very simple for this one. This principle says that if you have a triangle, say for example like this, if you know this side and you know this side, for example, and you know this angle, let's call it alpha. Let's call the angle alpha. You know, since alpha is too close to A, let's give it a different letter. Let's call it, beta. Okay? Now, we need to find the area, but let's use what we already know. We know that the area is equal to a half base times height. So this is, let's use this as our base, and let's see what we can do with the height. Let's call this the height. Okay? So we know this angle, we know this side, we don't know the height. So what formula do we know? What ratio do we know that involves this side and this side? These two sides relative to the angle that we have. Well, according to our understanding, we have a right triangle here. This is a right triangle. This here is the hypotenuse. This here would be the opposite. And according to our understanding for the trig ratios, the formula that deals with the opposite and the hypotenuse is sine, because sine of beta, or sine of, you could call it x, you could call it whatever you want to call it. We just give it Greek letters because they sound fancy, they sound sophisticated. So sine of beta is equal to opposite over hypotenuse, which is A, h over A. So now we need the h by itself. How do we get h by itself? We have to get rid of the A. So we multiply both sides by A. So we end up with A sine beta is equal to h. So now we have an expression for the height. So now we can go over into the formula half base times height, assuming that we know the base, and we know this, and we know this. Look what happens. So it's going to be equal to a half times our base times our height. What is our height? A sine beta. A sine. Guess what? We were able to find the area using the two sides we know and the angle that we're given. We're able to find the area. If we have two sides and an angle between them, we can calculate the area. So let's look at an example and see how it works. As I told you, the theory is more difficult than the actual application. So this is one. This is our first formula for the area of a non-right. It's not a right triangle, and we're looking for a formula. So if this is A, this is B, this is C, then we know that this is little a, we know that this is little b, and this is little c. That's the naming convention. Uppercase for the angle, lowercase for the side, and they're always labeled like this. The angle, side across from it. The angle, side across from it. The angle, side across from it. The area is, and here goes the formula. Ready? The formula is a half times this and this side times this side times the sine of the angle between the two sides. So it's half AB sine C. So if you know this side and you know that side and you know this angle, that's the formula. Suppose you know these two sides and this angle, then you could say it's a half AC sine of B. Or if you have these two sides and this angle, then it's a half BC. We always do it in alphabetical order. Put the first letter in the alphabet, followed by the next. So it's a half BC sine A. Notice that the sides that we're talking about, the angle is what is missing. So if it's A and C, then it's angle B. If it's A and B, then it's angle C. If it's B and C, then it's angle A. So I want you to be able to see the pattern. So going forward, once you have two sides and the angle between, you can find. So that's a side angle side. Once you have two sides and the angle between the two sides, you can calculate directly, straight off, the area of the triangle. So let's do an example. Example. So this one, let's call this, say, 36 degrees. Let's call this 10 centimeters. Let's call this 15 centimeters. So you're asked to calculate the area of that triangle. Before we add this class today, this would have been a challenging question. Now, we know that the area is equal to a half times the length of the sides, that's 10 centimeters, times 15 centimeters, times sine of the angle between. And that's going to equal to a half of 10 is 5, 5 times 15 is 75 centimeters squared, sine 36 degrees. So all I need to do is to take 75 times the sine of 36. So we take our calculator and we let the calculator do the work for us. So we end up with 75 times the sine of 36 degrees equal to 44.08 to 2 decimal places. So that's approximately 44.08 centimeters squared. And that's it. So now we have actually started learning how to calculate the area of a triangle that is not a right triangle. And see, once you know, it becomes easy. If you don't know, it's difficult. Once you have the two sides, you can do it. Okay? Let's do the next formula now that we want to go into is called Heron's formula. That's the case where you're given three sides, no angles, you're given three sides, and you want to find the area. This is how you do it. Basically, Heron's formula says that if you have any triangle, you're given the sides A, B, and C. So if you know the three sides and you're ready to find the area, but all you have is the three sides, nothing else. It's not a right triangle. You're given three sides and you need to find the area. Heron's formula says you find a half the perimeter of the triangle. So you do it in 2 steps. Step 1, you find S, which is a half the perimeter of the triangle. Find step 1. Find S, where S is equal to a half A plus B plus C. So it's the perimeter. A plus B plus C is the perimeter, but S is a half of the perimeter. So it's a semi-perimeter. Semi is a half. Okay? So we add A, B, and C, add them together, and multiply by a half, or divide by 2. And then the next thing says that the area is going to be equal to the square root of. You ready for this? This is a formula now. It's going to be S times S minus A times S minus B times S minus C. That's it. This is Heron's formula. 2 steps. Find a half the perimeter, and then the area is going to be the square root of half the perimeter times the difference of the perimeter and each side, the product of the difference. So S minus A, S minus B, S minus C, and you're multiplying them all together, boom, there is your answer. So let's do an example. Isn't this good? We're making progress. We're actually learning new things. Like I promised you at the very beginning, every week we learn something new. So let's do an example now. Okay, example. Find the area of triangle ABC. Let's go with 10. Let's go with 8. Let's go with 7. So that's our triangle, 10, 8, 7. Calculate the area. Well, step 1 says S is equal to a half times the sum of the 3 sides. So it's 10 plus 8 plus, to make it easy, let's use an even number. Let's make it easier. Let's call this 6, just to make it easy. If it was 7, it doesn't matter, we just get a decimal. Who cares? But just for the purpose of our conversation, let's keep it simple. So 10 plus 8, 18 plus 6, 24. A half of 24 is 12. Let's double check. 10 plus 8, 18 plus 6, 24. Times a half, 12. So that's step 1 completed. Step 2 says the area is equal to the square root of 12, that's S, times 12 minus 10 times 12 minus 8 times 12 minus 6. That's going to be equal to, and again, it's patience. 12 times 12 minus 10 is 2. 12 minus 8 is 4. 12 minus 6 is 6. So that's going to be equal to the square root of, and you multiply these things together, what do we get? So 2 4 is 48, so it's 12 times 48. And that gives us 576. Let me double check. So it's 24 times 24. Okay. 576. Okay. Of course, the square root of this is going to be equal to 24. And of course, it would be good, it would be proper to write 24 square units. So if it was centimeters, it would be 24 square centimeters or centimeters squared. If we had inches, it would be 24 square inches or 24 inches squared, whatever you want to say. If it was meters, it's 24 square meters, etc., etc. So that's the process. Let's do another one. Let's do another one. Let's go 20, 16, and 12. Find area of this triangle. And that's triangle A, B, C. Okay, so step one, the solution. S is equal to a half 20 plus 16 plus 12. Okay? What is that equal to? That's 10 plus 8, 18 plus 6, 24. The area is going to be equal to the square root of 24 times 24 minus 20, then 24 minus 16, then 24 minus 12. So that's equal to the square root of 24 times 24 minus 20 is 4. 24 minus 16 is 8. 24 minus 12 is 12. And then we go find the square root of, we can multiply those, and then there you go. So it's 24 times 24 times, sorry, mistake. So it's 24 times 4, 8, 32 times 12. And that gives us 9216. I like to double check my numbers because it's a habit that I have. So we go 8 times 12 is 96 times 24 times 4 equal to 9216. And now I need to find the square root of that. So it's second square root, so it's 9216. and I get 96. According to this, I'm getting 96. And therefore that will be squared unit. What I'm going to do now is I'm going to do 96 squared and see if I get that number. Square it, and I get the same number. So there it is. Isn't that cool? So we found the area of a triangle using two methods, of a non-right triangle using two methods. One is where we have a side, an angle, and the next side. So two sides and the angle between. We can use a half AB sine C, or if you're given three sides, we can use Heron's formula. Okay? At this point, I would like to transition over into the law of sines. Okay, we're hitting some very big points today. So we're going to do law of sines today, and next week, or next session, we'll do the law of cosines. Okay, here we go. I guarantee you, many students in high school would never have seen this. They would never have done this. So you're at an edge. You have a cutting edge with this extra step that you've learned. Okay, here we go. So based on our previous conversation, when you're doing the trig ratios, opposite, hypotenuse, adjacent, hypotenuse, opposite and adjacent, you need a right triangle. That's when you're doing the ratios. However, there are other things you can do with trigonometry that does not involve right triangles. And that's going to make your life a lot easier because right triangles are too limited. You don't go around in life and seeing everything, it's a right triangle, it's a right triangle. No, you have triangles that are irregular and they're not right triangles. What do? Well, this is one of the tools that I'm going to give to you or share with you that will be extremely helpful. So, here we go. By the way, even if it looks like a right triangle, if you're not told it's a right triangle, never assume it is. So unless you see the sign or you're told it's 90 degrees or you're told it's a right triangle, don't make any assumption. Let's call this A, B, and C. Again, the names, the letters, the labels are symbols. I could use any letter I want, it doesn't matter. We know that the side across from this angle is called side B. The side across from this angle is called side A. The side across from this angle C is called little c. The law of sines says that the ratio of the sine of angle A and side A will be the same for angle C and side C, and also the same for angle B and side B. The law of sines says that the ratios are all equal. Very important, extremely important. What does it say? It says that sine of A, angle A over little a, is the same as sine of angle B over little b. It also says it's the same as sine of angle C over little c. So anytime you have a pair of angle and its corresponding side, plus one more piece of information for the triangle, you can find all the missing pieces. Wow, that's big. That is so big. I'd like to share also, if this is true, then if you flip the fractions, then you'll also have the same situation. For example, if 2 is equal to x, then 1 over 2 will also be the same as 1 over x. If x and 2 are the same, then if I flip them, then they will always be the same. So, coming back to this, if I'm finding an angle, if I'm trying to calculate an angle, this presentation works perfectly. If I'm trying to find one of the sides, A, B, or C, it would be better if I flip the fractions and write them like this. A over sine of A, then that would have to be equal to B over sine of B. And then of course it's also equal to C over sine of C. What is the point? Saying if I'm finding the length, then using this presentation is easier to work with. If I'm finding the angle, using this presentation is also easier to work with. So depending on what you're trying to find, you decide which one you want to use. However, if you didn't take stock and you just use one of them, it doesn't matter. You will eventually get the right answer. So let's go and do an example. Let's try an example, it's whatever. Okay, so if this is 50 degrees, this is 14, and I told you that this is 95 degrees, and I say to you, find A. Find C, and also find angle C. So here it is. You're asked to find this side, and the missing angle. So of course, we know that the missing angle is very easy because all three angles of a triangle must be equal, must add to give us 180 degrees. So when you add the three angles, you must get 180 degrees. So if this is 95 and this is 50, add this to this, we end up with 145. So this has to be 35. Okay? So this is 35. So now let's go ahead and find and calculate A. We have a pair of angle and corresponding side. We also have this angle, so therefore I can find side A. According to the law of sines, A over sine 95 degrees, see, this over the sine of the angle must be equal to 14 over sine of 50. Then all I have to do is to solve this equation to get A, game over. So how do I get A by itself? I have to get rid of the sine 95, and I'm dividing by sine 95, so I need to multiply both sides by sine of 95. So we end up with A equal to 14 sine 95 over sine 50 degrees. And that's approximately equal to, this is when you take your calculator and your calculator will do the work for you. So we go 14 times sine of 95. And that's equal to 13.946, da, 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 da. And I'm going to divide by sine of 50. And that gives me 18.2, approximately 18.2. I'm going to one decimal place, so it's 206. So the answer is 21. So I'll round up 18.21. Notice this is 50 degrees, that side is 14. So this side is 95, it's bigger than 50. So therefore the opposite side A must be bigger than 14. So 18.21 looks reasonable. This is 35 degrees, this is 50. So if 50 degrees give you 14, 35 degrees must give us a smaller value than 14. Yes? So when we find C, it better be smaller than 14, because if it's not, it means we made a mistake. Okay? So we have found this, and we have found A. Let's go and find C. Well, C over sine 35 is equal to 14 over sine. Notice I did not use the 18.21, because if I made a mistake with this and I put it here, I would end up making a mistake for C. So if I can find C without using this number, then this is a safer way to go. And then what do? Get rid of the sine 35 by multiplying both sides by sine 35. We end up with side C equal to 14 sine 35 degrees, all over sine 50 degrees. And remember, we must get an answer that's smaller than 14. Here we go. So we go 14 times sine of 35 degrees. And that's equal to 8.03. And I'm going to divide that by sine 50. Sine 50. And that gives me 10.48. Approximately 10.48. 10.48 is less than 14, makes a lot of sense. So look at this. If you were asked, you could have found the perimeter now because you have all three sides. And you can also find the area of the triangle. So there's a lot of stuff that can come into play right here. So this is the law of sines. So I'm going to show you how this could help you if you're trying to find the area of a certain type of triangle because of what information is given to us. So let's try another example. So far we're doing great. We're achieving a lot today. I will not touch the law of cosines because it's a little bit more involved. I'll rather do that next session. So for today, I'm just going to use this and show you how this can be applied in other settings to make your life a lot easier. So let me cover this up and clean the board, and then we'll go. Okay, here we go. Of course, it says triangle ABC. It could be triangle PQR. It could be triangle XYZ. It could be anything. The names are not significant. They're just symbolic. They're just positions. That's all. If I gave you this, Yes, there it is. So if I say to you, find the area of this triangle, you're gonna ask yourself the question, okay, what can we do? Do we have three sides? We have one, two, we don't. We don't have the third side. Okay. Do we have a right triangle? No, we don't. What's the other option we have? Oh, do we have two sides and an angle between? We don't know the angle between. Wow, we're stuck. So we say, man, we're stuck. We need help. Is it possible that I can end up finding this angle so that I can ultimately find the area by multiplying a half this times the sine of this angle? Is there anything that we know that will help us to find angle C? And the answer is maybe. Look at what we have. We have a side, an angle, and its corresponding side. We have 50 degrees and the side across from it. We have this side, but we don't know that angle. So we could use the law of sines to find angle A. Once I know angle A, because I already know B, I can add this and this together, subtract it from 180, boom, that's my angle C. Once I have angle C, I can use the formula. Area is a half, this times this, sine of C. So you see, we want to go, we know our goal, we know our destination, but before we can get there, we have to do some things. We have to take care of some things first before we can get to that point. And truthfully, that is how life is sometimes. Sometimes you might have to take a detour to get to where you're trying to get. And we need to be able to recognize when we can't go directly to our goal. We cannot get directly to where we want to go, our destination. But sometimes we have to pause a little bit. Sometimes we have to step back in order to go forward. Keep that in mind. So this is a classic example right here. Even though I'm trying to find the area, I cannot go right away and find the area. I have to do some things. And then I'm in a position where I can get the area. So let's go ahead and try and find angle A, because that's the only thing we can do right now. We have to find angle A because we're stuck. So angle A, sine of A over 16 is equal to sine of B, which is 50 degrees, over 12. Quick question, let's see if you're paying attention. Is angle A going to be more than 50 degrees or less than 50 degrees? Is angle A going to be more than 50 degrees or less than 50 degrees? Well, angle A on the B is 50, this is 12. If this is 16, this has to be an angle that's bigger than 50. So A has to be bigger than 50. So make sure we end up with an answer that's bigger than 50. So now, how do we get sine A by itself? We need to get it up to 16 by multiply both sides by 16. So sine angle A is equal to 16 sine 50 over 12. Okay, I'll tell you from now. I have not, I'm just writing it out of my head, so I don't know if the numbers will work together. So let's keep our fingers crossed. So this is actually equal to, divide this by 4, you know, with 4 sine 50 over 3. Now we grab our calculator and we do 4 sine 50. So it's 4 times sine of 50 degrees. And that's equal to a number. And then we're going to divide. Okay, this is not good. This is not good because when I divide by 3, I'm going to get an answer that's greater than 1. And sine cannot be greater than 1. So I need to make an adjustment. I need to make this number, say, 14. I need to make that number 14. And if that number is 14, we We can't do that, so let's leave it as is and just work it out. We never discussed that before, but sine cannot be greater than 1. Sine of an angle cannot be greater than 1. Sine of an angle ranges between -1 and +1. Maximum +1, minimum -1. So now let's do this now. I just made a quick shift, so let's go. 16 times sine 50, sine of 50, is equal to 12.256 divided by 14, and that gives us 0.8758. 8755 4 decimal places. So sine of A is approximately equal to 0.8755. So to get rid of the sine, we have to do the inverse of sine, which is sine to the -1, or arc, that's ARC. So sine, so A is equal to sine to the -1 of 0.8755. And I was saying to you that sine to the -1 can also be written as arc. Arc sine 0.8755. I'm mentioning it to you so that if ever you see arc, ARC, arc sine, arc cosine, arc tangent, it's the inverse of tangent, it's the inverse of sine, it's the inverse of cosine. Just wanted to be aware of that. Okay? And then you use your calculator, and usually it's the second button along with the sign. So in this case, second, and we do sine, and it's 0.8755. And that's going to give us 61.104. So that's approximately 61 degrees. Let's round it to 61 degrees for the purpose of what we're doing. So it's 61 degrees, 8755, 61 degrees. So if A is 61, B is 50, what is angle C? So angle C is going to be equal to 180 degrees, take away 50 degrees plus 61 degrees. We add these two and subtract it from 180. So it's 180 minus 111 degrees. Okay, and that gives me 69 degrees. So we know that C is going to be 69 degrees. So now that we know that this is 69 degrees, I can use the formula. I have 16 times 14 sine of 69. So the area triangle ABC is equal to 1/2 times 16 centimeters times 14 centimeters times sine of 69. And all I have to do is to take the calculator in hand. 1/2 times 16 is 8. And then it's just 8 times 14, which is 112. So it's 8 times 14 times sine of 69. 69 degrees. That gives us a grand total of 104, approximately 104.56 square centimeters. So let's go over the steps one more time and see what we just did. We just, first of all, we got this triangle. We have two sides, but we did not know angle C. We did not know angle C. But our goal is to find the area. And there was no way we could go immediately to find the area. However, we could take care of some pieces and then end up at the end finding the area. So what did we do? We analyzed our situation and realized that the best move was to find angle A. That was the best move. And we found angle A by using the law of sines. Sine of angle A over side A is equal to sine of angle B over side B. And then solve that and end up with angle A as approximately 61 degrees. Once we had angle A as 61 degrees, knowing that angle B was 50 degrees, we were able to determine that angle C was 69 degrees. And there it is right here, 69 degrees. Once we have angle C as 69 degrees, now we can apply the first formula that we learned today concerning calculating the area of a non-right triangle when we have two sides and the angle between. Two sides and the angle between 69. We know we did a half the sides, the product of the sides times the sine of the angle between. And we end up with 104.56 centimeters squared. Wow, that's a lot of math. So let's do another one, and I think it will get us into a better place where we know that, this is what we do. So let's try another one. This was a lot of math we just did. This time, I'm going to move away from the letters A, B, and C because I don't want it to feel we must always have those letters. Okay, so find the area of triangle PQR. Okay, so let's use this as 30 degrees. Use this as 20. Okay. Okay, and use this as 15 centimeters. Okay? So let's go. How do we find the area of triangle PQR? Well, we have this side and that side. We don't know this side. We have this side and this side. If we found this angle, then we can find the area just like that. So maybe we need to try and find angle R. So the question is, how can we find angle R? We don't know the angle, we don't know the side. However, we know that the three angles give us 180 degrees. So maybe if we can find this angle, and we already have this one, then these two will help us to get R. Yes, that's the way to go. So let's go to work. I need a sip of water. Okay, here we go. This is when we use the law of sines. So we see the law of sines showing up to be very, very important. Law of sines, we're trying to find angle R. We'll say sine of angle R over, no, we can't go there. We can't do that immediately. We have to do that later. So we're gonna go find angle Q first. Sine of Q over 20 is equal to sine of P over 15. So sine of Q over 20 is equal to sine of P, which is 30, over 15. Multiply, we end up with sine Q equals to 20 sine 30 over 15. Now, I already know that sine of 30 is a half, but you might not know that. 20 times sine of 30 is going to give us 10. So suppose you didn't know and you type it in your calculator. Let's see what the calculator does. 20 times sine of 30 equal to 10. So this is equal to 10 over 15, which is just 2/3. So Q, angle Q, is going to be equal to sine to the -1 of 2/3. And when you use your calculator, that's approximately, take the calculator in hand and do sine to the -1. So sine to the -1 of 2/3. And we end up with 41.8. So let's call it approximately 42 degrees. Just to keep it simple, 42 degrees. So now we know this is 30. We know this is 42. Okay? And now we need to find R. So measure of angle R, it's equal to 180 degrees, take away 30 degrees plus 42 degrees. Of course, you realize that my diagram is not to scale. Okay? But that's okay. So it's equal to 30 plus 42 is 72. It's going to be 108 degrees. So now we know that angle R is 108 degrees. We know the two sides that create the angle. So now we can find the area. So area of triangle PQR is going to be equal to a half times 20 times 15 sine of the angle R, the angle between them, which is 108. And that's approximately equal to a half times 20 is 10. 10 times 15 is 150. It's 150 sine 108. So we clear and we go 150 times sine of 108. And according to my calculator, it's approximately 142.7. I'm reading with centimeters, it's 142.7 centimeters squared, since it's area. Okay, so that's how we do that. And of course, just to recap Heron's formula, which was the highlight of today, I'll just do a quick question using Heron's formula, and here we go. So P, Q, R. So we could go here and put 30, 26, and let's put 14. Okay. Okay, let's see. All right then. So, according to Heron's law, we do S equal to a half, 26 plus 14 plus 30. And that's equal to 13 and 7 is 20. 20 and 15 is 35. Let's double check. 13 and 7, 20 and 15, 35. And the area is equal to the square root of 35 times 35 minus 30, 35 minus 26, and then 35 minus 14. Okay, and that's going to be equal to the square root of 35 times 35 minus 30 is 5. 35 minus 26 is 9. 35 minus 14 is 21. And from here, we use a calculator, it's the square root of 35 times 45 times 21 equal to 33075. 33075, 35 times 45 times 21. I just need to find the square root of that, and the answer is 33075, and we end up with 181, approximately 181.9. So no unit was specified. So the answer is going to be unit times unit is unit squared, square units. And that's Heron's law, or Heron's formula. And compared to when we just started learning together, when you see how our material has evolved, and now you're doing big things. I might have to pull back a little bit and start slowing down again, and then build back up. Slow it down, build back up. So give me one more class, which is next session, to do the law of cosines, and then I'm going to go into coordinate geometry, the equation of a line, parallel and perpendicular lines, etc., etc., etc. So we're going to pull back and do some easy stuff again, and then build us back one more time. So again, on behalf of the BROSIS Foundation, we thank you for joining us in this Learning Together session. And I do hope that you did get something out of this, or if you did not, that your mind has been triggered to realize that you can find the area of a triangle even if it's not a right triangle. You can find the area of a triangle without using a half base times height. Thank you for joining us, and enjoy the rest of your day. Thank you.